Oh my gosh, graphing systems of linear inequalities. That's just ridiculous. Okay, I promise it's really not. This is just combining some of the things that we've already learned, and we're doing it just a little bit further. So let's say I've got the inequality y is greater than x, and that's my graph. Okay, before you say, what? That's not even possible. Remember, just because it doesn't have a plus or minus and some number here, as in like +2 or -4 or whatever the case may be, it just means that its y-intercept is actually 0. And x by itself means that it's 1. So if I were to graph this, that means that y is greater than 1x. So my starting point for this line would be at the origin, which is 0, 0. And then because it's 1x, because I don't have to show the 1, that's like 1 over 1, that means I go every space up 1 over 1, up 1 over 1. And if I went backwards, same idea, right? Okay, this has, what kind of line, what kind of line would I make from that? Is that open or closed or dotted or solid? If we were graphing, we would know that that's that open circle, open circle, which an open circle is also like a dotted or dashed line. So I would do a dashed or dotted line for this line right here. Okay, now to shade it, remember, pick a value, any value you want. So for this one, I'm going to pick the point. You pick any one you want and try it for yourself. But I'm going to pick the point right here, where I have 4, -3. Let's plug that in. -3 is my y value, so -3 is greater than 4. Is -3 greater than 4? No. So we know this is not it, and that means it has to be something on this side of that line. Okay, now I'm halfway there. What if I gave you a system of linear inequalities and I gave you a second inequality you've now got to graph? So let's do that. What if I gave you the one to put on top of that and I say y is less than or equal to -x plus 2? All right, let's start off by graphing it. We know that this plus 2 means that's my y-intercept. That's where I start, and I would say that's at the point where 0, x is 0, y is 2. It's right here. Now, -x, that's like -1x, which is like -1 over 1, so I'd say down 1 and to the right 1, down 1 to the right 1, down 1 to the right 1, and so on and so forth. Now, again, since it says or equal to, is that an open or closed circle? You should say it's closed circle, which in our case means a solid line. So my solid line would look as best as possible like this. Okay. Now, again, I've got to pick a value. Now, what I got to do is I got to look over here and pick something that's not on one of the two lines. It'd probably be the best. So let's pick the point, any point you want. I'm going to pick the point, let's say right here. That's at the point 5 and 2. That's a 5, and you know it. That's a 5 and a 2. So plug those values in. I say 2 is less than or equal to negative, and then I plug in 5 plus 2. Okay, 2 is less than or equal to, what is -5 plus 2? -3. Is 2 less than or equal to -3? It's not. That does mean then that this value it should be on the left side of that line, which is over here. Okay, now I've graphed those two together. What do you think that means then is then what solution would work for both of those lines? Anything that fits into this space would work as a solution for both of those lines. So let's pick a point then that would be true statement. Let's pick the point, let's pick right here, which is at the point x is -6, oh that's hard to read. At the point x is -6, y is 0. And I'm going to do that on the next page, and let's see. So like I said, I'm going to take that in here. I have -6 and 0. Those are my values. That was my solution for both of those. And let's see if that's true. Meaning, if those numbers work for both inequalities, then that I shaded it properly, and I have graphed that system of linear inequalities. So my first my first inequality was y is greater than x. Plug those values in. So we have a y value of 0. and we have an x value of negative 6. Is 0 greater than negative 6? Yes, so that works. Now the other inequality was y is less than or equal to negative x plus 2. Plug those values in, and let's say 0, because that's our y value, is less than or equal to negative, and in this case it was negative 6 plus 2. Now again, this might get confusing. You need to remember that this negative sign is independent of whatever negative sign may be with our x value. So we have negative 6, which is actually like positive 6. 0 is less than or equal to, what is positive 6 plus 2? 8. Is 0 less than 8? So what I'm saying is that that little area, that little triangle that we graphed and that we shaded right in the middle, any number you pick in that area would be a true statement for both of those inequalities. So let's do another one. So let's start with our inequalities. Let's do y is greater than x minus 1, and let's also have y is less than 1/2 x plus 2. Let's make that or equal to. All right, for our first one, and in yellow, we say y is greater than x minus 1. So we know that our y-intercept, or our starting point, is negative 1. So we'd say x is 0, y is negative 1, is right there. Since it's y is greater than x, that's like 1x, or 1 over 1x, which means up 1 over 1, up 1 over 1, and so on and so forth. Right. Okay, is that a dotted or a solid line? Since it's not underlined, we know that that means it is a dashed or dotted line. And it would look like that roughly. Okay, in white, since that one is underlined, we can go ahead and just remember, is that a dotted or dotted or solid line? We should say that's a solid line. Now to graph it, we would say that our starting point right there is 2. So that's x is 0, y is 2 is right there. Now we have 1/2 x. That's already given to you as a fraction. So you say up 1 to the right 2, up 1 and to the right 2, up 1 and to the right 2. There it is. And we would do that like this. Okay. And again, I'm sorry, we already said that that is a solid line. So now we've got to actually graph them both. So for our yellow line, let's start there. Pick any point you want. I want you to do this too. I want you to pick any point you want for the yellow line and see what happens. I'm going to pick the point, since it's me, I'm picking the point for the yellow line. Let's go with right here, which is at the point 4 and negative 3. Now let's plug that in. Y is negative 3 would be our y values, greater than, and it was originally just x, so we plug in 4 minus 1. Negative 3 is greater than, what's 4 minus 1? 3. Is negative 3 greater than 3? No. So that means this has to be graphed somewhere in here. Okay? Our yellow side, meaning any value on this side of our yellow line, so here's our yellow line, any value on this side is true. And I'll do that. I'll pick one over here. Let's pick the point right here, which is at negative 3 and 3. So we have right there negative 3 and 3. Plug those in. We'd say that y is 3, I'm running out of space. If y is 3 is greater than, x is negative 3 minus 1. 3 is greater than, what's negative 3 minus 1? Negative 4. Is that true? Bing. So this is right. We're good. Now for our y value, pick any y value you want. So since that's getting messy on the left side, I'll pick this one over here. I'll say 5 and 0. Let's plug it in. Y is 0, less than or equal to 1/2. Ooh, I should have picked a different number. Let's change that to a 6 and move it over here. It'll make sense in a second. 1/2 of 6 plus 2. The reason I did that because 1/2 of 5, then we're dealing with decimals. All right, 1/2 of 6. Okay, so 0 is less than or equal to, what's 1/2 of 6? That's 3 plus 2 is 5. Is 0 less than 5? Yeah. So that means this does work. So it's got to be something over on the right side. Okay, that means it's anything down here will work for that line. And let's, to test, just to make sure, let's say you picked one on the top, meaning if you pick something over here of the white line, let's pick one of those points right now. Let's pick the point right here. Oh, I did it again. Let's pick the point right here. Let's plug those values in. This value right here is negative 6 and 3. Uh-oh, I'm definitely running out of space. So 3 is less than or equal to 1/2 of 6, negative 6 plus 2. Okay, 3 is less than or equal to, what's 1/2 of negative 6? It's negative 3 plus 2. 3 is less than or equal to, what's negative 3 plus 2? Negative 1. Is 3 less than or equal to negative 1? No. So we know it had to be something on this side of the line. Now what you got to tell yourself then is that I know that it's got to be somewhere between these two spaces, these two lines. So I know it's got to be above this yellow line, like as in it's to the top and to the left, and it's got to be somewhere below this white line. So I know that my true value that will work for anything in here is one of these spaces. So let's pick one and test, just to make sure it's really true. Let's pick, how about right here? This is in the middle. I know this is getting really messy. So this is at the point negative 4 and negative 2. I'm going to go to the next slide just to test that. But there's our point, negative 4 and negative 2. So I had my solution, which was negative 4 and negative 2. My first inequality was y is greater than x minus 1. My other was y is less than or equal to 1/2 x plus 2. Okay, let's plug those values in. This is my y value. This is my x value. So y, we say negative 2 is greater than, now I say negative 4 minus 1. Negative 2 is greater than, what's negative 4 minus 1? Negative 5. Remember with negatives, is negative 2 greater than negative 5? Good job. Let's try it with our white line now. Our white, inequality. We pick that value, we say negative 2 here and negative 4 there. So we say negative 2 is less than or equal to 1/2 of negative 4 plus 2. Okay, we're almost there. Negative 2 is less than or equal to, what's 1/2 of negative 4? Negative 2 plus 2. Negative 2 plus 2 is what? 0. So is negative 2 less than or equal to 0? Awesome.